So what we're looking at here is these worded algebra problems, which then we use to solve the or worded algebra scenarios rather, which then we use to solve a situation or a problem. Now with these, what we're doing is we're looking at an independent variable and a dependent variable, and often very good things. These things things that work very well here are time and money. So like I say in the, or something in money, time and money works really well. So like I said up on Compass, it's a good idea to think things like mobile phone plans, because the mobile phone plans, they have a flagful or a connection fee. So that may be, I don't know, 30 cents to connect. And it might be $2 per minute. So just like in last year's test, the candle problem, there was a startup fee. So this is your startup fee, and this is your rate that's claimed per minute. So for every minute, every independent variable, it goes up by 2 dependent variables. So you give information like that. So you say, there's a company that costs 30 cents to connect and $2 per minute, and then there's another one that charges maybe 50 cents. A bit clearer if I wrote that. 50 cents to connect, but charges, say, $1.50 per minute. And then from there, what you do is you say you have, say, Telstra, for example, might be one of them. Optus would be the other one. And then you get the person doing the test to write down what the test would be. So for Telstra, this is Telstra, that's what Telstra charges, this is what Optus charges. It'd be 0.3, because they charge, plus 2n, where n is a number of minutes, or it could do t or whatever. So I think, and for Optus you'd say 0.5 plus 1.5 n. So, so that's why you do that. So then from there you could ask other things like, what is the so you expect someone to graph it, and one graph would look something like this, the other graph would look something like this, and you'd ask, how much does Telstra charge for 5 minutes? How many minutes do you get for $3 for Optus? At what point do they have the same cost? At what point? So then you'll ask for an intercept. That's where simultaneous equations comes into it. They're all the different things that you can ask based on these questions. So that's your scenario. So think about that. Another thing that works really, really well is, say, if you're working with things like something, I don't know, say cards, for want of a better thing. And there's cards and there's also envelopes. Now the idea is someone's giving out envelopes and cards as well, and someone gives out 3 cards plus 2 envelopes, and that there is then someone receives 50 cards, for example. So then from there, you've got to work out how many cards in an envelope, but you've got to word it so it's worded correctly. But that's how you go about these algebraic scenarios and all the different things that come from there.